That'd be pretty funny.
It's a 5-minute distraction before we actually start doing what we're supposed to. Okay, so this right here is a graph that displays the normal distribution. And we've already talked about this a lot. This right here, 1 standard deviation away. So how much would we expect to be in here? 68%, broken up into 2 parts, right? Do you have to memorize 68, 95, 99? You sure do. Okay. 3 numbers. You need to know that 68% lies within 1 standard deviation away. 95% lies within 2. 99.7, I think it says, lies within 3. Now, when you hear teachers say that they grade on a curve, what does that mean to you?
My grade goes up.
My grade goes up, right? Because that's not really what grading on the curve is. The standard curve, if I were to truly grade on a curve, that means 68% of you would get a C. And even fewer would get a B, and very few would get A's and F's. But most of you would get a C. So, you'll take it? My D's are like, will do. So, when you hear grade on a curve, what the teachers are doing is taking the high score and making that the new high, right? That's not a true grading on a curve. We don't like when teachers grade on a curve because my B's are now C's. They go lower because not very many will be up in these ends. A couple things that will happen if you have a true normal distribution. The maximum will be at the center right here, the median. It will peak right there and then it goes back down. It's symmetric. And the mean, median, and mode will be the same thing. Like we've already discussed, about 68% of the data will fall 1 standard deviation away. 95% will fall within 2. 99.7 fall within 3. If there's an outlier, it's going to be in this range, 3 or more deviations away. If you get rid of an outlier, all of those numbers become more accurate. So we're going to analyze this normally distributed data. Is this in fact a normal distribution? Is it symmetrical? No, but there's so many data points that it's pretty close to symmetrical, right? It's pretty close to a normal distribution. So the first question says, what percent of men aged 25 to 34, which is the data that we're looking for, or we're looking at, how many of them are 69 through 71 inches tall? Now, if these were 6 men, 12 men, 34 men, 34, and if these were numbers, it would be kind of difficult to do. But the Y bar right here, the Y axis, is percent of men. So it's already given to you in percent. What percent are between 69 and 70? Well, 69 is right here. How many people is that? 13. So that's 13. This one would be kind of in the 16 range. And this one would be 14. If you add all of those up, what do you get? So about 43% age of men aged 25 through 34 are that tall. Suppose the survey included data on 100 people, 100 men. How many men is this talking about? So we need to see what is 43% of what? 100. Nice thing is 100, it's 43. If it were 200, you would do 43% of 200 or 500. So they surveyed and 43 men said they were in that range. The mean of the data is 70. Right here is our average. And the standard deviation is 2.5. Approximately what percent of men are within 1 standard deviation away from the mean? Now, if it were a true normal distribution, we would say 68%, right? It's not quite, so we can figure that out though. What do we have to do in order to figure that out? We need to find the range, right? We know the standard deviation, we know the average. How do I find the range? Right? 70 plus or minus the 2.5. If I subtracted 2.5, it would be 67.5. If I added the 2.5, it would be... No, we don't really have the 0.5, so we're going to go from 68 to 72. So what percentage is in the 68 range? About 11. We're estimating. The 72 is at about 12. So what? This would be one standard deviation on both ends. What percent fall in that? Add them up, we get 66%, which is pretty close to what we expect, right? 68, 66. Great, that's all we're doing today.